Okay, this video is on perpendicular and angle bisectors. One of the key words right off the bat is equidistance, which I think is pretty easy to understand. It's the idea that two things can be the same distance from each other, right? Equidistance. When a point is in the same distance from two or more objects, that point is said to be equidistant from the objects. Perpendicular bisector is a bisector in a triangle, usually like this, where the bisector comes down through the vertex angle there and cuts the base in half, producing two congruent segments. We call it a perpendicular bisector because it is also perpendicular to that base. So the perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment, which is to say, if this point or this point or this point or this point is on a perpendicular bisector, which is in this case, then all of these distances are congruent to the other side, obviously not to each other. Right? So this distance and this distance are congruent. This distance and this distance are congruent. This distance and this distance are congruent. So on and so forth. So we also have the converse of that. And remember, the converse just means that we're replacing the hypothesis and the conclusion. And basically it says if there is a point equidistant from the endpoints of a segment, then it lies on the perpendicular bisector. Okay? So it just flips around what we just talked about. In this case, instead of points being on a perpendicular bisector being equidistant from the endpoints, if the points are equidistant from the endpoints, then they lie on the perpendicular bisector. We're talking about points being on the perpendicular bisector. So for the converse theorem, we can talk about all of these points, and all of these points would be the locus, right? And locus just means a set of points which satisfy the given condition. Okay, so those points are in the locus. That's perpendicular bisectors. Let's talk about angle bisectors for a second. So here we have an angle, and here we have the bisector of that angle. And there are some things we want to know. The angle bisector theorem says essentially if this is an angle bisector, which I'm telling you it is, then points on the angle bisector are equidistant from each side. And we know that that distance is always going to be the perpendicular to those sides. The converse of that one is interesting too. It basically says if there are points in here that are equidistant from each side, then those points, or the locus, right, lie on the angle bisector. Just the converse of what we just talked about, but it's saying all of these points are equidistant from these sides. I know it doesn't look drawn that way, but we're saying that's the case. Okay. We can say that because that's the case, they must lie on the angle bisector because points on the angle bisector are always equidistant from either side of the angle. I'm going to throw an example problem in here just real quickly. One of the problems you're going to come across a lot is this idea of writing an equation of a perpendicular bisector of a given segment in slope-intercept or point-slope form or whatever, one of the forms we've learned in algebra. This goes back to, we've actually talked about this before. When we were talking about reflection, you'll remember we talked about, okay, how do we figure out the distance between these 2 points? And we know the distance is a perpendicular distance. And we even came up with sort of a weird formula for it. I'm going to go through the process real quickly just to show you. This is actually a little bit easier than what we've done before. So let's assume we have 2 points. Point A is -1, 6. Point B is 3, 4. And you can see this example in your book too if you're looking. It's on page 303. So we're going to be looking for the perpendicular bisector of this segment. The first thing you want to do is figure out, okay, if it's going to bisect this segment, it's got to go through its midpoint. So we're going to need to use midpoint formula. And the midpoint formula, remember, is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. And so that works out to -1 plus 3 and 6 plus 4. This is 2 divided by 2. This is 10 divided by 2. So we get 1, 5 is our midpoint. So we know the midpoint is definitely on the line. That helps. The other thing we have to find is the perpendicular bisector of this thing, which means we need a line that's perpendicular to the line that goes through these 2 points, which means we're going to need slope. So we have to find slope between these 2 points, which if you remember is y2 minus y1 over x2 minus x1. So in this case, we end up with -2 over 4 or -1/2. Perpendicular slope to that is the opposite reciprocal, which is going to be +2. So now we know we're writing an equation for this line, and we know a couple of things. We know it's going to be in the form y equals mx plus b. In this case, we know m because we know it has to be the opposite reciprocal slope. That's 2. X is still the variable. Now there's this key part about what b is going to be. To find b, we have to plug in that midpoint because we know it has to go through that midpoint. So let's do that. Let me move my work up here for a second. And let's go through finding. So instead of y and x, I'm going to write 5 equals 2 times 1 plus b. And we're going to solve for b. 5 equals 2 times 1, so 5 equals 2 plus b. Subtract 2, b must equal 3. So the total equation we have here is y equals 2, remember, is that opposite reciprocal slope. X plus 3 is that b we just found. And there is the perpendicular bisector of this segment. Okay, I think that's probably the most challenging thing you're going to see in this section. Just remember those 2 theorems and their converses that we have now to use for our proofs. That's the distance and perpendicular bisector theorem and the distance and angle bisector theorem. And then the 2 big vocabulary pieces are the equidistance, which I think, again, is self-explanatory, and locus is just a group of points that satisfies a certain condition. Have a great night, guys.